This video covers section 3.6 from your text, and basically we are going to be finding the equations of lines. We're going to use two different forms. We're going to review slope-intercept form, but then we're also going to use a new form called point-slope form. So just to start off with a little bit of review, hopefully you remember what slope-intercept form is. Remember, it's the form that we want to use, especially when we have a slope m and we have a y-intercept given as the ordered pair 0, b. Remember, for y-intercepts, x is always equal to 0. You see that right here? X is always equal to 0. What is that form? Can you write it in the box? Do you remember what it is? Hopefully you will remember that it's y equals mx plus b. We're still going to be using that quite a bit, but there's going to be a new form that we're talking about today, which is called point-slope form. And let's go ahead and write down what that is. The point-slope form of the equation of a line with slope m that passes through the point x1, y1 is the equation y minus y1 equals the slope m times x minus x1. So, and then just as a little bit of review, remember we also talked about the y's up slope formula. How do you find this slope of a line between 2 points, or that passes through 2 points? You y's up. M is equal to y's on top, y2 minus y1, the y's are up, over x2 minus x1. So we're going to use all these tools today. But how do we know which one to use? You know, why would we use, first of all, slope-intercept form, y equals mx plus b? Well, there's two things that are specifically given in this equation. One is the slope and the second is the y-intercept. So you want to use this form when you are given those two things. When you're given the slope, and that's m, and the y-intercept, the ordered pair 0, b. Now, we're not always given those things. We might be given something else. So there's other scenarios where you might want to use point-slope form. However, you could still use maybe some of the other form as well. One scenario is when you're given the slope m and a point, just any generic point. We'll call it x1, y1. But the second scenario where you might want to use this form is if you're given 2 points. Call the first point or ordered pair x1, y1, and a second point x2, y2. Okay, and we'll look at some examples of how to do these sorts of things. The first example says find the equation of a line with slope 4/3 and a y-intercept of 0, 2. Well, this tells us two specific things. This right here tells us what about the line? It tells us m equals 4/3. And then we are also given this information. This information tells us what? It tells us that b is equal to 2. We know we have y equals m x plus b. If I plug in that information, we get the linear equation y equals not mx but 4/3 x plus b, but b is 2. And that's review. We've done that before. But we also have some other newer examples. For example, find the equation of a line that contains the point 3, 5 and a slope of 4. And then it says in parentheses here, write your answer in slope-intercept form. We know that to mean that we want to write in y equals mx plus b form. And here we're given some information. The point, remember, we can think of this as an x1 and a y1. And of course this is our m. And we know this is a case where we want to use the other form though. We want to use slope-intercept form, or point-slope form. Use point-slope form when you're given the slope and a point. So if we're given the slope and a point, and the form looks like y minus y1 equals m times x minus x1, we go ahead and plug in the information. We're always going to leave the y part first, but we have a y1. That's the y coordinate of our point, which in this case is 5. So we have y minus 5 equals our slope m, which in this case is 4. Parentheses, leave the x, but our x1 is 3, so it's x minus 3. Now you'll notice that what we have so far is not in this form. It's not in the correct form. So we got to do some algebra to solve for y. We need to solve for y. Need to solve for y, which we should all know how to do. We know when we're solving equations, the first thing we want to do is get rid of parentheses. So if I distribute, I have 4x minus 12. We should all be comfortable doing that. And then to get y by itself, what do we need to do? Change sides, change signs. So this negative 5 becomes a positive 5. And that gives us that y is equal to 4x, negative 12 plus 5 is negative 7. So our equation is 4x minus 7. Okay, hopefully that makes sense. Notice that that we used point slope form. This is point slope form. And what were we given in the problem? We were given a point and a slope. We were given a point and a slope, hence why it's called point slope form. Now we have a third example here. It says find the equation of a line that passes through 2 points. So this is a little different than the first two. The first one we were given the slope and the y-intercept. The second one we were given the slope and a point. But here we're given 2 points. And what's different about this one is we don't have a slope. So we need to first find the slope. Can you think of a way that we know how to find a slope if we're given 2 points on a line? And I hope everybody is thinking the same thing I am. You should be telling me one statement right now. You should be saying, Stricker, wise up. M equals y2 minus y1 over x2 minus x1. We need to know the slope. And we know how to find it like that because we have an x1 and a y1. And we have an x2 and a y2. So when I plug in that information, y2 minus y1 is negative 2 minus 1. Remember to be careful with your signs here. And then x2 minus x1 is 4 minus 8. Simplifying, we have negative 3 on the top, negative 4 on the bottom, which simplifies to a positive 3 over 4 because a negative divided by a negative is a positive. So we're going to need that. And now we have a slope, but we also have 2 points to pick from. So you might say, well, let's use point slope form. Makes sense to do that. We have y minus y1 equals m times x minus x1. We can go ahead and again plug in the information that we have. We can use either of the 2 points. I'm going to go ahead and use the first one because there's no negatives in there. But you can use either point. Just want to reiterate that. You can use either point. So if I use the first one, though, I have y minus 1 equals our slope of 3/4. Uh-oh, fractions. We'll be okay, don't worry. X minus 8. So this is y minus 1. Let's get rid of our parentheses. 3/4 times x when we distribute. 3/4 times x. And then we have this other one. We have 3/4 times negative 8 over what? Over 1. 4 goes into 8 twice. So this is really 3 times negative 2, which is negative 6. That's not that bad. So it's going to be minus 6. And then, of course, to solve for y, because we want to put in slope-intercept form, we need to move that to the other side. We need to add 1. So we get our equation. We get y equals 3/4 x minus 5. Okay, there is one other way to do this problem, and that's using slope-intercept form. Sometimes people will teach their students how to only use slope-intercept form. You can actually use slope-intercept form if you have a point and a slope. And here's the way it works. You have to kind of do 2 steps. So we take our y equals mx plus b, and we plug in a point and the slope. So we have a y point. The y point is 1. Then we have m, which is 3/4. And our x would be 8. So if we use the point 8, 1, this is our x and our y. So this would be times 8 plus b. Remember, we already did this calculation. We think of this as 8/1. 4 goes into that twice. So this is 1 equals 2 times 3 is 6 plus b. And if I move that 6 to the other side, it becomes a negative 6. And that tells us that b is equal to negative 5. So we then have our equation. We have y equals 3/4 x plus b, but b is negative 5. Notice we got the same answer we got the first way. So if you feel more comfortable doing it that way, you can always choose to use slope-intercept form if you like. Okay, we got a few more examples now dealing with parallel lines and perpendicular lines. So the next one says, find a line that is parallel to this line and passes through the given point. Write your answer in slope-intercept form. So you remember what we learned about parallel lines? Parallel lines have what? Parallel lines have what kind of slope? They have the same slope. So if the line that we're looking for is parallel to this line right here, that means our slope is going to be what? It's going to be the same. So our slope is going to be 3.2, because if I look at this line, the slope is 3.2. It's the coefficient in front of the x, that number there. And then we're given a point. We're given the point 4.5, comma 51.3. You can go ahead and use point slope form. We have y minus y1. What's y1 going to be? 51.3. Then we have m, which is 3.2, times x minus x1, which is 4.5. Again, we want this answer to be in slope-intercept form, so we need to solve for y. We need to go ahead and distribute. So I have y minus 51.3. 3.2 times x is 3.2x. Then we have 3.2 times negative 4.5 is 14.4. So we have negative 14.4. But then I want to go ahead and move that negative 51.3 to the other side. So it becomes a positive 51.3. We'll go ahead and Simplify here, we get y equals 3.2x, and if I subtract that away from 51.3, I get 36.9. We get y equals 3.2x plus 36.9. Notice that both of these lines have the same slope, which means they're going to be parallel. One last example here for this section. We want to find a line that's perpendicular to the given line. Remember, if two lines are perpendicular, what can we say about their slopes? That they are opposite reciprocals or negative reciprocals of each other. So I guess first we need to know what the slope of this line, what's m equal to for that line? Well, to do that, what do we need to do? We need to take that line and put it in slope-intercept form. We need to put in slope-intercept form so we can tell what m is, because right now we have no idea what m is. So if I take 9x minus 12y equals 4, it's a good thing we know how to solve for y, right? We want to go ahead and change sides, change signs. So we're going to subtract 9x over there, which gives us negative 12y equals negative 9x plus 4. That's a positive 4. There's no sign in front of the 4 there. And then we want to go ahead and divide everything by negative 12. Everything. Negative 12, negative 12. So when I do that, I get y equals negative divided by a negative, and then we can go ahead and reduce here because they're both divisible by 3, so that's a 3. This is going to be a 4. So this is going to be a positive 3/4 because we had a negative divided by a negative times x. And then this also reduces. 4 goes into 12 3 times, so this is minus 1/3. And we don't really need the y-intercept. What we're really looking here for is the slope. So this tells us that the slope of our given line is 3/4, which means our new slope is going to be what? The negative reciprocal of that, which is negative, since that was a positive number, and then instead of 3/4 we have 4/3. So plugging in what we have here, we have y minus y1, and we have to be careful here with the sign. It's going to end up becoming a plus 2, right? Equals a slope of negative 4/3 times x minus x1, which is 6. And then we go ahead and simplify. This becomes y plus 2, the double negative rule. Distributing, we have negative 4/3 times x is negative 4/3 x, and then do some math off to the sides here. We have negative 4/3 times negative 6 over what? Over 1, because it's a whole number, so we write it over 1. Of course, 3 goes into 6 twice, so this is negative 4 times negative 2 is positive 8. So this is plus 8, and now solving for y, move this positive to the other side, it becomes a negative 2. We're almost done. We get y equals negative 4/3 x plus 6. So now we've learned how to write linear equations knowing certain information, and especially we just learned how to write linear equations if we know 2 points on a line. So now let's see how we can do that, find a linear model if we have some real-world data points. So we have an example here. We all know PG&E. PG&E calculates your electrical bill based on the number of kilowatt hours of electricity you use. If you use more than a specified baseline quantity of kilowatt hours, you are charged a higher rate for the usage that exceeds the baseline. 1 month, a local household was billed $44.88 for 408 kilowatt hours. The next month, the same household was billed $56.32 for 512 kilowatt hours. if both months' usage did not exceed the baseline, or excuse me, in both months the usage did not exceed the baseline, what is this household being charged per kilowatt hour, and how do you know? So remember what we talked about with slope and what slope means. It's saying what is it being charged per kilowatt hour. Per, that word per, suggests that we have a rate going on. And whenever we're talking about a rate, we're trying to figure out the rate. That means we're trying to find what? The slope. And so to do that, we know we need to y's up, y2 minus y1 over x2 minus x1, which means we need 2 points. But you know what? We have 2 points because we are given 2 different scenarios for this family, 2 different months. 1 month, the bill was $44 for 408 kilowatt hours, and then the next month it was $56.32 for 500 kilowatt hours. Now, with that information, what is going to be the X and what is going to be the Y? So the X is going to be the kilowatt hours, because that's the input. That's what you plug in to find out what the Y is. The Y is the charge or the cost to use those kilowatt hours. Because you have to remember, X determines Y, and so you would use kilowatt hours to find costs, not cost to find kilowatt hours. So this is like our X's, these are our Y's. So if we take those 2 scenarios, that's really 2 separate points. The first month, when we had 408, the charge was 44.88. And then the second point was when we used 512, the charge was 56.32. Now we can use those points with our y's up. So if we subtract the y's, we have 56.32 minus 44.88. And then on the bottom, we have 512 minus 408. Okay, now we can go ahead and calculate that. If you want, you can pull up your calculator. We have 56.32 minus 44.88. When you do that, that's 1144. 512 minus 408, that's a little bit of a easier calculation. What does that come out to? 104. Right? Okay, so then let's go ahead and divide that. Let's take that 1144 and divide it by 104. And you get 0.11. So this is 0.11, or it's 11 cents per what? Remember, it's a rate. It's the charge per kilowatt hour. So it's 11 cents per kilowatt hour. And you want to ask yourself, does that answer seem like a plausible answer for a rate? Does that seem like it is reasonable? I think so. So that's the slope. Okay, part B says find an equation to model the costs of the electricity. Well, this is a linear model, right? It's a linear model, so we have a constant charge for the electricity. And so if we want to find an equation to model it, we need to use the y equals mx plus b. Remember, or the other form you can use, there were 2 different ones you can use. You can also use point slope, y minus y1 equals m times x minus x1. Okay, I'm going to go ahead and use the second one this time, but you can use either one. So if we use the second one, we have y. Let's go ahead and pick the first point. Numbers are a little smaller. So when we do that, y minus y1, the y1 is what? It's the
4488, and that equals the slope, which is 0.11. We found that in part A, times x minus x1. The x1 is the 408 minus 408. Okay, let's go ahead and distribute that 11 cents. So when we do that, we have 0.11 times x, 0.11x, and then 0.11 times 408. That's 4488. And what's going to happen there? What happens when we solve for y? If we add that to the other side, we see something happen. Those cancel. So what we're left with is just that y is equal to 0.11x. In other words, there is no like baseline charge. Now some companies you might see that they charge like a monthly fee no matter how much electricity you use, and so there might be a Y-Intercept which represents some fee they have to pay no matter what, plus the price per kilowatt hour. But for this particular family, they're just paying 11 cents per kilowatt hour, and that equation, y equals 0.11x, will tell us how much they have to pay. And that kind of brings us to part C. Does PG&E seem to be charging a flat fee in addition to the charge per kilowatt hour? And the answer is no, because there is no Y-intercept. Now, you will be doing some problems in the homework where you do have to, you will find a Y-intercept. So there might be some flat fee, there might be a fixed fee, whatever you want to call it. There might be an original population. Remember, B is always like the initial amount. The Y-intercept is always the initial amount.
That does it for this section. Make sure you do your My Math Lab homework, and we will see you in class. Thanks.